Hello and welcome. This is Cambridge O-Level Chemistry paper number 2, theory part. This is October-November 2020 exam. The subject code is 5070 and this is version 2 of this paper. Let's start. Section A. Answer all the questions in this section in the spaces provided. The total marks for this section is 45. So question number 1. Choose from the following compounds to answer these questions. Each compound may be used once, more than once, or not at all. So the compounds which are given to us are aluminum sulfate, ammonia, calcium carbonate, carbon dioxide, chlorofluorocarbons, copper 2 sulfate, hydrogen chloride, potassium nitrate, sodium chloride. Okay. So first question. It says which gas dissolves in water to form an alkaline solution. Okay, so which compound again dissolves in water to form alkaline solution? So here in this we have ammonia. So ammonia gas dissolves in water to form ammonium hydroxide, and ammonium hydroxide is a base and that is an alkaline solution. So ammonia is can be a good choice from here. Ammonia. Number 2, which compound is an anhydrous solid which can be used to test water? So remember remember copper sulfate is an anhydrous compound and can be used to test water. So add copper sulfate to water, a blue precipitate will form, and this is a test for water. So copper to sulfate. Number 3, which compound contains ions with 3 positive charge? Okay, so let's see. 3 positive. So first compound, aluminum sulfate. So aluminum sulfate will be AlSO4 2 3. So in this case we have aluminum with 3 positive ions and sulfate SO4 with 2 negative ions. So aluminum sulfate will be the choice. Aluminum sulfate. Now number 4, which compound is a solid used in flue gas desulfurization? So flue gas desulfurization, calcium carbonate. So calcium carbonate is a compound that is used to desulfurization. So it is calcium carbonate. What happens? So when any gas or when the flue gases do contain sulfur in them. So once they pass through it, so calcium sulfate is formed, or calcium sulfide is there, and carbon dioxide is released, which is further decomposed or removed from the desulfurization system we have. Then part E, causes eutrophication. So eutrophication, potassium nitrate, ammonia, anything can be a good option. So we have potassium nitrate, yes, ammonia is also there. So any of these two can give you the option. So potassium nitrate and ammonia, anyone can be a good choice. So potassium nitrate is better choice than ammonia, but both of them give us eutrophication process. So this is how you answer first question, and this is a question that is common in almost all the exams. So these and it basically involves a lot of things from memory. So make sure when you're preparing for this, I strongly recommend that you solve at least past 5 years paper, both November and May, in order to have this thing or this sort of questions or prepare better for these sort of questions for the exams. Next part. Question number 2, it says part of structures of chlorine and sodium chloride are shown. So chlorine structure and sodium chloride structure are shown. A part, it says explain in terms of structure and bonding why chlorine has low boiling point and sodium chloride has high boiling point. So remember, chlorine is a gas, sodium chloride is a solid, first of all. Then this is a gas, and this is formed in molecular structure or Cl2. This is NaCl. This is a covalent compound. This is ionic compound. This has we overall the weak intermolecular forces. Ionic compound have strong intermolecular forces, and these are the primary reasons why uh, we need or why in order to boil chlorine gas you need high I mean the amount of heat required is much less than boiling sodium chloride. So let's try to write this thing down. So chlorine gas is in its molecular state is Cl2. There are covalent bonds, or there is a, you can say, covalent bond between the chlorine atoms, or between two, it's better to write between two chlorine atoms. The covalent bond presents weak intermolecular forces and can be easily broken by application of heat. Okay, so then on the other hand, sodium chloride or NaCl contains ionic bonds, ionic bond between Na positive and Cl negative ions. The ionic bond presents strong attractive forces between these ions. It takes high amount of heat energy to break these bonds, thus higher boiling point compared to chlorine gas. Okay, so this is how we can write this thing. Next part, what is the electronic configuration of chlorine atom? So remember the atomic number for chlorine is 17. So So let's try to break this. So first at shell will have 8, second shell will have, oh sorry, first shell will have 2, second shell will have 8. So then the next cell will either have 8 or 16. So 8, so there are no 8, so 7, remaining 7 will be in the outermost shell. So this is how is the electronic configuration of chlorine will go. Part C, the electrolysis of molten sodium chloride is carried out using graphite electrodes. What is the meaning of electrolysis? So electrolysis is breaking down of any solution with the help of electricity. Uh, so we can write it as electrolysis is the breaking up of an electrolyte using electricity. Okay. Then part 2, state the direction and movement of positive and negative ions when molten sodium chloride is electrolyzed. So for example, this is in this beaker, or in this crucible, we have um, sodium positive and Cl negative ions, or a molten sodium chloride. We have a graphite electrode here. We have a graphite electrode. So this is positive, this is negative. Okay. So positive ions, so the direction of positive ions. So positive ions will move towards the negative electrode, and that negative electrode is called cathode. So move towards the negative electrode, that is cathode. Negative ions move towards the positive electrode, and the positive electrode is anode. Okay, so this is how we write this. Next part, state one observation that can be made at the positive electrode when molten sodium chloride is electrolyte. So again, let me draw it for you. For example, this is we have the positive electrode. So this is the negative electrode. So positive, negative. This is molten sodium chloride. Na positive, Cl negative. So what is happening at the positive uh, electrode? So chlorine gas is released. So these Cl negative ions are going, and they are basically making chlorine gas over there. Uh, So, so, so what is so observation we can see, and this with this observation basically they want us to um, say what is practically happening. So practically in this chamber we'll see some gas coming out, and the observation for gas is some sort of bubbles coming out. And the other thing, chlorine gas has a very distinct color, so it is greenish in nature. So we can write these any to the best is uh, you can say bubbles of chlorine. Oh, gas can be seen, and also chlorine gas has a greenish color. Okay, so chlorine gas has a greenish color as well. It's a greenish color. So if you can write bubbles of chlorine gas can be seen, this is fine because the 1 point question, so one observation is good. So then give the formula of the two negative ions present in aqueous sodium chloride. Okay, so now we have an aqueous solution. So this is a molten solution. So molten solution do not have any you can say water based ions, or that are H positive and OH negative, or hydroxyl ions and hydrogen ions. So in sodium, aqueous sodium hydroxide, so NaOH, sorry, my bad, NaCl, and this is aqueous. So aqueous solution is basically NaCl plus water. It contains Na positive plus Cl negative plus H positive plus OH negative. So these will be the ions. So we have to find two negative ions. So negative ions are chlorine negative and OH negative. So there will be chlorine ions and hydroxyl ions, OH negative ions. Okay, then part B, it says when aqueous sodium chloride is electrolyzed, hydrogen is produced at the negative electrode. Explain in terms of transfer of electrons why hydrogen, not sodium, is produced at the negative electrode. Okay. Okay. So hydrogen, and so in terms of electron transfer, why hydrogen, not sodium, is produced at the negative electrode. So first of all, hydrogen ions gains or electrons more easily than sodium ions, because sodium uh, is much higher in the electrochemical series than hydrogen. Okay, so this is the reason why we can say that in terms of electron transfer. So electrons, number one, hydrogen ion gains electrons, and why? Because they are much, hydrogen is much lower in electrochemical series than sodium, or in other way, sodium is much higher than hydrogen in the electrochemical series. Okay. Then part E, in this question, they're asking us that part A. So part E, it says a 36.3 gram 36.3 gram sample of compound contains 14.4 grams of carbon, 0.6 grams of hydrogen, and 21.3 grams of chlorine. Number one, calculate empirical formula of the compound. So what are the elements we have? We have carbon, we have hydrogen, and we have chlorine. First, write the MR. So with carbon, the molecular mass, or uh, atomic mass, carbon is 12, hydrogen is 1, chlorine is 35.5. Okay, and in the compound, we have 14.4 grams of carbon, 0.6 grams of chlorine, and 21.3 grams of uh, chlorine. Okay, so first of all, let's try find out the ratio. So ratio, uh, uh, it's just simply by uh, or we call it ratio, or number of moles. That is better choice, number of moles. So number of moles, the formula, mass in grams over molecular mass or atomic mass. So So 14.4 divided by 12. This is for uh, let's say moles for carbon. So let me write it here. So 14.4 divided by 12. This is 0.6 divided by 1. This is 21.3 divided by 35.5. So number of moles, this is 1.2. This is 1.2 moles approximately. This is 0.6 moles approximately. This is 0.6 moles approximately. Okay. So now it's in order to have the empirical formula, multiply it by a factor that gives it multiply or divide by a factor that makes it a whole number. So let's say divide by, you can call it LCM or least common factor. So LCM, say if you're going to divide it, so 1.2 divided by 0.6, 0.6 divided by 0.6, 0.6 divided by 0.6. So this comes out to be 2, this comes out to be, so this comes out to be 1, this comes out to be 1. So empirical formula will be first carbon, hydrogen, chlorine, carbon comes with 2, H and Cl. This is your empirical formula. Okay, so this is how you calculate the empirical formula. Then part 2, relative molecular mass of the compound is 181.5. Deduce the molecular formula. So remember, molecular formula is N times empirical formula, and this N is mass divided by mass of empirical formula. The mass is 181.5 and mass of empirical formula is uh, 12 into 2 plus 1 plus 35.5. This comes out to be approximately equals to 3. So N is equal to 3. So 3 multiplied by this formula. So 3 into C2HCl. So molecular formula is C6H2, oh sorry, H3Cl3. This is your molecular formula. Okay, so this is how you do it. Next part, question 3. It says a drop of black ink is placed at the bottom of a beaker. After a time, the color of ink spreads throughout the water. Explain this observation in terms of kinetic particle theory. So so this is a beaker of water, and say this is a drop of ink, and what will happen? The ink will, or the drop of ink will diffuse through the water, uh, and soon the overall color of the water becomes consistent. So this is or we have to basically explain this with the help of kinetic particle theory. So now what kinetic particle theory states in this case? So let's write, or before I write, let me explain it to you first. So what is happening is that the ink is diffusing in this water from a region of high concentration to a region of low concentration. So the particles in the ink molecules move randomly across the water, and they collide with the molecules of water, and this collision results in you can say diffusion / mixing of ink inside the water. So we have to basically write this whole thing in terms of or we have to write, or we have to rephrase this whole thing in this paragraph. So let's try to do that. So the color of the ink diffuses let diffuses color of the ink diffuse through the water from a region of high concentration to a region of low concentration. The particles of ink move randomly in water, comma, colliding with water molecules. This movement causes diffusion slash mixing of ink in water. Okay, so it is very important that you have to use the word diffusion, use the word movement of particles of ink, collision of particles of ink with water, and the diffusion is actually movement of molecules from a region of higher concentration to a lower concentration. Okay, so these are the 3 or 4 points which the examiner will be looking for your answer in this question. Okay, next part, question B. It says in the past, ink was made from a mixture containing iron 2 ions and tannic acid. Describe iron 2. Describe a test for iron 2 ions. Okay, so iron 2 ions. So remember, iron 2 ions they readily convert to iron 3 positive ions. So the just simply test is to add aqueous sodium hydroxide. Extra sodium hydroxide. So any solution that is containing this will uh, go and in a solution of aqueous solution of say sodium hydroxide will have Na positive OH negative ions, uh, and this will easily convert it into ferrous 3 ions. Okay, whatever the solution the output would be. So what will form? So the iron solution, there will be some or ink solution. This is basically ink solution, and ink solution will the OH and with H positive ions as well, they start reacting with tannic acid and OH goes there, and eventually a precipitate of iron forms. So you can say greenish. So remember, iron 2 positive is reddish brown in color, iron 3 positive is greenish in color. So we have a green precipitate of Fe3 positive, salt or iron, what you can call it. So observation, green precipitate date formation uh, on green precipitate formation of or green precipitate, you can say not formation, green precipitate of iron 3 positive ions can be seen. It is uh, of Fe3 positive ions can be seen. Okay, then part 2, ink darkens when used on paper. This is because iron 3 is oxidized to iron 3 positive ion. So interestingly, they have done the same thing or they have told us the same concept in the next part. So write down the ionic equation for it. So the ionic equation, so iron 2 positive loses an electron, becomes iron 3 positive. Okay, so this is one way of writing it, or you can also write it iron 2 positive, oh, this arrow goes, so iron 2 positive becomes iron 3 positive and have this positive. So in some textbooks you'll find this equation, in some textbooks you can find this thing. This both equations are the same. Generally this equation is more common in the books, so you can go with that. Otherwise, if you're writing it like this is also fine. Both means the same, or actually what is happening, so iron 2 positive is losing an electron and becoming iron 3 positive. This is or this flow gives a better picture of it. Otherwise, I mean, the literature goes with that. That is also fine. So iron 3 positive gains an electron and becomes 2 positive. That is also fine. So part 3, after a time, ink fades because of hydrolysis reaction, which is catalyzed by acid. State how a catalyst increase the rate of a chemical reaction. So catalyst basically decreases the activation energy required for a reaction to take place. That is as simple as that. So you can just simply write the catalyst decreases the activation energy required for a chemical reaction, thereby increasing the rate of reaction. Okay, next part. It says paper is made of cellulose. Cellulose is complex carbohydrate, that is polysaccharide. Name one other complex carbohydrate that is also a polysaccharide. So remember, polysaccharide are is a form of glycans. They are starch, glycan, galactogen, cytin, anything you can use. So good one is, or a simple one, starch is a good answer for that. You can also write word glycogen. Also go with galactogen. Uh, Also go with cytin. So these are all form of complex carbohydrates or polysaccharides. Okay. Then part 2, describe how complex carbohydrates can be hydrolyzed to simple sugars. Okay, so this is for 2 points. So remember, first of all, hydrolysis, how or exactly is, or what exactly is hydrolysis? Hydrolysis is basically the breaking of carbohydrates into its constituent sugars. Okay, and the hydrolysis generally takes place in presence of water or OH negative or hydroxyl ions, and it can also be, it also takes place in presence of certain acids, or by heating or boiling of carbohydrates. So this is how the, or we can easily convert carbohydrates to sugars. So explain this process. So you can write hydro oh, hydrolysis takes place in presence of water or OH negative ions. Uh, it can hmm, so you can say carbohydrates can be they go with an S, so hydrolyzed to sugars by heating or boiling them, heating or boiling them, um, or treating them with water or OH negative ions. And you can also have treatment with acids, OH ions or acids. So this is how you can send it. And also remember, uh, hydrolysis is breaking down of polymers to monomers using H2O, or you can say it, the definition of hydrolysis is breaking of carbohydrates to its constituent sugars using heat slash water, uh, or in the presence of both heat and water, is called hydrolysis. So this is overall what hydrolysis is, and you can explain this thing using this information in your own words as well. So the two things they are looking for is that that hydrolysis is breaking off down of carbohydrates into its constituent sugars, uh, and other thing they want to know is that it can be done in the presence of water or OH negative ions or acids, and it can also be done with using heating or boiling them as well. Okay, so next part, question number 4. So for water from natural resources contains dissolved substances which are not pollutants, such as mineral salts. Name another substance found naturally in water which is not a mineral salt or a pollutant. So water is a good source of oxygen for a body. So oxygen is also present in water, and that is not a mineral salt or a pollutant. It says when lithium reacts with water, aqueous lithium hydroxide (LiOH) and hydrogen are formed. Construct the equation for this reaction. So lithium plus H2O gives you lithium hydroxide plus hydrogen gas. Okay. Now we have to balance this equation. This is very important. So we have one lithium, two hydrogen. So we have OH. So we have one O and one H extra. So if we have well, so we can go with this and we can go with this. So now we have 2 and 4H, so 4H, 2O, 2O. So O and H are balanced. So now we have 2 lithium. So just multiply 2 here. So this is a balance equation for this. So always remember, whenever you have to write the equation, they will give you these constituents or the reactants and the products, but you have to balance the equation in order to have complete credit for your answer. Then part C, sodium and potassium reacts with water in a similar way to lithium. Explain in terms of electronic configuration why lithium, sodium, and potassium all react in similar way. So remember, lithium, potassium, sodium, all are group 1 elements. They have one electron in their outermost shell. So the way they react will be same. Or in when if you have to explain it from an electronic configuration, the reason is that outermost shell for all these elements have one electron. Remember, all these elements have one valence electron in the outermost shell. Okay, that is why the reactions are same. Then describe the trend in reactivity of group and elements lithium, sodium, potassium. So as we move down the group, the reactivity increases, and the reason because that the the, the valence electron gets far away, or the valence shell gets far away from the nucleus, and it is much easier to remove elements from a larger atom, or in an atom which has valence shells much farther away compared to an atom which has the valence electron much nearer to the nucleus. Okay, the reason is reactivity decreases, oh sorry, increases as we move down in group 1. This is because the electrons in larger atoms are far from the nucleus and can easily be removed. Okay, or can easily take part in a reaction as well. Okay, this is how you write this down. Then question D, it says water and oxygen are formed when aqueous hydrogen peroxide decomposes. So we have aqueous hydrogen peroxide that it decomposes into water and oxygen. Calculate the maximum volume of oxygen at room temperature and pressure, which produce the complete decomposition of a solution containing 16.0 grams of hydrogen peroxide. So remember the formula which we'll be using here is PV equals to nRT, and the value. So let's see what values which are given to us. So just calculate the maximum volume of oxygen at room temperature and pressure. So at room temperature, remember room temperature, it's good to have this temperature as 25 degrees C or 27 degrees C. A good value is 25. So 25 degrees C, so the temperature is 25 plus 273, and this comes out to be 298 kelvins. This is the temperature in kelvins we have. So we have the value of temperature. The value of R is 0.0821, and pressure, room temperature and pressure is 1 atm. Pressure is 1 atm. And remember the units for R are atm, not liter, not mole, not Kelvin. So remember 1 liter is 1 decimeter cube as well. So we have T, we have R, we have P. So now we have to find out N. Okay, so let's find out N. N is number of moles of gas at room temperature. So maximum volume of oxygen. So we are looking for oxygen. So we have 2 moles of H2O2 results in 1 mole of O2. So it means that if we have 16 grams of H2O2, how much moles or grams of oxygen will be there? So first of all, see H2O2 is or molecular mass of H2O2 2 plus 16 into 2, 34 grams. So for 16 grams, moles for 16 grams, moles, we have 16 divided by 34. So these are the number of moles, and this will produce, you can say 16 by 4 moles, and this number of moles will produce oxygen. So moles of oxygen we have, so it becomes a little messy. So let me make it a little clear. N is number of moles we have. So for 16 for we have 16 by 34 moles. So this is H2O2. This is oxygen. So we have 2 moles. It provides 16.4 moles divided by 16 by 32 divided by 2, or 16 by 32 divided by 2. Yeah, that's right. So these number of moles of oxygen. So for moles of oxygen, so 16 by 34 multiplied by 2 moles of O2. So this is the value of N we'll be using. Okay, this is the value of N we'll be using, and with this value, now let's put these values in the formula and see what is our result. So pressure is 1 multiplied by volume we have to calculate. N is let's try to calculate it into decimals. 8 divided by 34. So this comes out to be 0.235 3 approximately number of moles, and 0.8, oh sorry, 0.0821 multiply by the temperature 298. So let's multiply it. 298 multiplied by 1, and this comes out to be volume. It equals to 5.7566 centimeter, oh sorry, decimeter cube or liter cube. So this is approximately what you will be getting after. So another way, some people use 27 over here, so they multiply it by 300. So if you have used 8 as or the value as point, uh, so I mean the answer would be 5.7566 decimeter cube. The marking in the marking scheme, you will see answer 5.65 decimeter cube. This answer is also fine. I mean, again, since it's in the marking scheme, it is good. So it is 0.23 multiplied by 108 multiplied by 298. So 0.235 multiplied by 0.082. So I mean, it is fine. I mean, we have done the calculations right. There is a little bit of you can say round off calculation errors in our calculation and in the ones which they have used in the exam. So both of these answer, if you have shown this working correctly, uh, that you have used this formula and this formula with these values and have shown how we calculated number of moles of oxygen. This is 4.235 moles, and once you have shown all this working, this is fine and you'll be getting complete credit for this. Okay, next question number so it's the E part of this question. It says a fuel cell generates electricity when hydrogen and oxygen react on platinum electrodes. Name the process in name a process used in industry to produce hydrogen. So process, name a process used in industry to produce hydrogen. So this is electrolysis of H2O, of H2O. Another process is cracking. Cracking is another process which uh, used in industry to produce hydrogen. Okay. Then part two, it says some cars use hydrogen oxygen fuel cell instead of petrol or gasoline engine as a source of energy. Describe two advantages of a hydrogen oxygen fuel cell compared to a petrol and gasoline engine. The best advantage is that byproduct or exhaust or waste, it is water, and this is which is non-pollutant slash environment friendly. Then it is generally more efficient compared to fossil fuels. Overall, this process is more efficient. It is number 4, renewable source of energy. So these are three of advantages. You can write any of them. Although some you they only the byproduct is water, and you can so and it's environment friendly. Some students may consider them 2 points, but generally it is one single point, and people who have written as byproduct is water and it is non-pollutant, environment friendly, they are not very much appreciated by the examiners. They just basically want them it to be one single point, and then students to come up with something for the point number 2 as well. So then moving ahead, question number 5, it says alkenes are made in oil, sorry, alkenes are made in an oil refinery by cracking of hydrocarbons. Give one other reason why petroleum companies carry out cracking. So remember, cracking is used to produce hydrogen gas. Uh, it is also used to refine crude oil into useful commercial petroleum products such as petrol, diesel and other oils, because the crude oil contains a big chain of hydrocarbons which are broken into lower carbon, low chain of hydrocarbon compounds, and which are basically used as fuel products. So you can say make H2 gas or refine crude oil to generate useful fuel such as petrol. Okay. Then question number part 2 of this question: complete the equation of cracking of tridecane C13H28 to form propene C3H6 and one other compound. So C3H6, so 3 C's are gone, 10 C's remaining. 6H is subtracted from 28, so 28 minus 6 means 22, so H22 will be there. This is as simple as that. Then part B, propane is an alkene. Write the general formula for alkene. So it is CnH2n. As simple as that. Remember here C3H3, C2H4, C5H10, something like this. So this is how alkenes are. So it says propane reacts with steam by addition reaction. Predict molecular formula for the product of this reaction. So addition reaction adds oxygen to this. So so this is propene. So propene is C3H6, and it comes with an O addition reaction. So H2O also adds oxygen primarily to it, and also hydrogen to it as well. C3H8 and O, something like this. So predict it's C3H8O will be the best choice for that. Then part 3, it says when propene undergoes incomplete combustion, a small amount of carbon dioxide is formed and other two substances. Incomplete combustion always produces carbon monoxide. So one is carbon monoxide, or call it as CO, and the other is water. Combustion of this always produce water, so H2O. Okay, so this is the answer. Next question, part C, it says structure of propene is shown. Deduce partial structure of polypropene to show 3 repeat units. So remember, polypropene is a polymer, and this polymer will revolve around this uh, double bond of carbon. Okay, so this polypropene will, so we can write this compound as CH double bond CHH, and this comes out CH3, something like this. And when polymerization of this thing occurs, so this double bond breaks and it comes to be something like this: HHHH and CH3, something like this. So this double bonds comes out. So this is the partial structure of, or you can call it as N. So when we do polymerization of this, so polypropene, so let's say you can call it as you can say the base unit. Base unit is CH, CH3H, and this. This is my base unit N, and they have asked us to show a structure with 3 repeat units, to repeat it 3 times in the similar fashion: CH3, CH, oh sorry, CH3, HH. Now this is one structure. Then again CH, CH3, CH. This is second structure, and now third one, H, CH3, CH, H, and this, and showing this that this structure carries on. This is one iteration, this is the second structure, and this is the third structure. So this is how you draw a polypropene structure. And if it says that you have to have a generic formula for this polymer or polypropene polymer, so it is something like this. Okay, so this is, or this marks the end of section number A. Now in section number B, so there are in section number B there are total of 4 questions, and out of these 4 questions you have to attempt 3 questions. I'm not that lucky enough to I have to solve all these 4 questions for you at the moment here. So let's start. So question number 6, it says methonic acid and ethanoic acid are weak acids. Okay, what does the term weak acid means? What does the term weak means? So weak means when applied to acids. So remember, acid or the strong acids, you can say they fully dissociates in aqueous solutions or in water, or you can say it ionizes, it totally ionizes in water when that that a compound is added to water on. But weak acids, they do not completely ionize or do not completely dissociate in water, so they're called weak acids. So just simply the acid which does not or not does not weak acid which partially or weakly disassociates ionizes in a solution is called weak acid. Okay, so again, what does the term weak mean? So the acid which partially or weakly dissociate or ionizes in an aqueous solution is called a weak acid. So aqueous solution, you can also say aqueous solution, or called water. Okay. Uh, then part B, it says methonic acid reacts with magnesium powder. Write the equation for this reaction. So HCOOH plus magnesium, so it becomes magnesium COOH, and magnesium is M2 positive, this plus hydrogen. And so now again we have written the equation, now we have to balance it. So how to go and balance it? So we have COH as 2 times, so COH1, so 2 times here, H2, H2, COH twice, and so that now this is a balanced equation. So again, this is a metal. Oh, sorry, this is an acid reacting with the metal, so it becomes it forms a salt and a hydrogen gas. Then it says state and explain how the rate of reaction changes when the experiment is repeated with a piece of magnesium ribbon with the same mass as powder. All other condition remains the same. Include an answer about ideas about the collision between the particles. So what happens? So remember, with magnesium powder, the reaction is much faster compared to magnesium ribbon, because this area available for so for collisions, and in order for uh, reaction to take place is much higher compared to a magnesium ribbon. So in terms of collisions or between particles, let's write it as uh, so the rate of reaction decreases with emission ribbon as less surface area is available for acid and for reaction. The collision rate between the COOH negative ions and metal decreases, resulting in less rate of reaction, or decreased rate of reaction. It's a better word. In decreased rate of reaction. Okay. Then part C, it says methanic acid reacts with propanol C3COOH to form an ester. Name and draw the structure of an ester showing all the atoms of all the bonds. So the ester will be, so this is propanol and this is methanic acid. So it will be propyl methanate. Propyl methanate. So C3H7OH plus methanic acid HCOOH. So the reaction, the reaction will be, so one byproduct is H2O. So CO, this is the alcohol and this is acid. This is our acid, this is our alcohol. So here we have R dash OH, and this is, we have, you can call it R dash COOH. So with an ester, you can say you have not like this. You have this as HCOO dash R, something like that. So this goes as HCOO dash R dash. So we have to form the structure. So this is H dash C. This is double bond O and single O, and then becomes this goes like this. HCOH is here. As R dash COOH. So my bad. So this is O, and this comes out to be R dash, or R dash is R dash COH. R dash comes here, so R dash is C3H7. So this is the structure for that. So structure. Oil, This is the structure for propyl methylate. Okay. Then part D, it says name ethonic acid is present in vinegar. Name the organic compound which is converted to ethonic acid when vinegar is made. Name the ethonic uh, organic compound. So organic compound, ethonic acid, and so ethanol. So answer is, so will be ethanol. Okay. What is this reaction? So this reaction is an oxidation reaction. Uh, Oxidation reaction. Uh, then it says the table shows some properties of 4 carboxylic acids. Okay. So for carboxylic acid, ethanic acid, carboxylic acid. Okay. Predict the density of ethanic acid. Okay. So density of ethanic acid. So density will be so 1.2. It would be so density would be less than 1.22, and density would be greater than 0.99. Okay. So let's say 1.1. You can say approximately 1.1. Okay, so 1.1 grams per centimeter cube, so gram per centimeter cube. That's a good estimate. So remember, anything, any value between so density, any value between 1 and 1.21 grams per centimeter cube is a good choice. Is a good choice, because you can't say 1.2 to 1.99. It can't be. It can be anything between. So just select a safe value between 1.1, or say 1.12, to 1.15, something like that. Okay. Then it says describe and explain the change in boiling point as the number of carbon atoms in the molecule increases. So remember, the number of carbon atoms are increasing as we are going down. So the boiling point is also increasing. Okay. So describe and explain the change in boiling point. So first of all, boiling point increases as the number of carbon atoms increases. Now, why this is happening? The carbon atoms, you can say the carbon atoms or the increase in also increases the intermolecular forces increase the intermolecular forces. The molecules attract each other with more stronger force. Thus, more energy is required to overcome these forces to enable boiling. Okay, and therefore the boiling point rises. Okay. Next question, question number 7, which says iron is extracted or extracted from ore from iron ore in a blast furnace using limestone and coke. Name a common ore of iron. So common ore of iron is hematite. So remember, this is not bauxite, nothing else. Remember, it is hematite. So okay, so some students do mix, confuse it with bauxite, and bauxite is generally for aluminium. Then part B, the coke burns to form carbon dioxide. This reaction is exothermic. The question is explain in terms of bond making and bond breaking why this reaction is exothermic. So remember, what is happening? So C plus O2, it is forming CO2 with heat. So carbon and oxygen double bond is broken and carbon oxygen O2 bonds are formed. Okay, so so what is happening here? The bond formation. So explain in terms of bond making and bond breaking why this reaction is exothermic. So remember, the bond formation of carbon dioxide results in release of energy, uh, i.e. that is an exothermic process. And this energy released is more than the energy absorbed during the bond breaking process, that is endothermic. The overall energy is released to the surrounding and making the overall process as exothermic. So explain in terms of bond making and bond breaking why this reaction is exothermic. So the bond formation for CO2 results in release of energy, that is the thermic process. This energy released is more than the energy absorbed during the bond breaking process, uh, i.e. oxygen oxygen double bond. Bond breaking process of O2 bond, that is endothermic process. So together the overall energy is released to the surroundings, making the process an exothermic problem, exothermic in nature. Okay, so this is how we can explain this whole phenomena that is happening. The one of the mistakes people make is that they can confuse bond formation uh, as exothermic and or they basically interchange endothermic and exothermic process. So bond formation, remember, bond formation is exothermic and bond breaking is endothermic. Here we have oxygen oxygen double bond is breaking, and the new bonds carbon between oxygen carbon double bond oxygen is forming here. So this is exothermic process. So this is formation, this is breaking. So this, there is some heat, that is, it is an endothermic process. It extracts heat from the surrounding, and this basically generates heat to the surrounding. And that is why this whole process is exothermic, because eventually this is the heat that is given to the surrounding, and this is more than what is the heat that is extracted from the surrounding. Okay, then question number the part C for this question. The carbon dioxide reacts with hot coke to form carbon monoxide. Carbon monoxide reduces iron 3 oxide to form iron ore. Use this equation to explain why the iron 2 oxide is, or iron 3 oxide is reduced. So iron 3 oxide, remember, removal of oxygen is also reduction. So removal of oxygen is also reduction. So, or addition of oxygen is oxidation, removal of oxygen is reduction. So you can use this thing. So iron, it contains oxygen, the oxygen is removed. So we can easily write oxygen is removed from iron 3 oxide, which results in oxidation. You can use this. Also, iron 3 is Fe3 positive, and this is Fe here. So iron has gained electrons, and gain of electrons is also oxidation. So gain of electrons for Fe3 positive, gain of 3 electrons for Fe3 to become Fe, and this also means oxidation. Gain of electrons is also oxidation. So the easiest part that can easily seen from here is the one with the oxygen. So both, if you can write both of them, that's fine. Your marking schemes gives this answer, and this is also good. Then question number C, part 2, it says calculate the maximum mass of iron when 1.25 grams of iron 3 oxide react with excess carbon monoxide. Okay, so now first of all you have to calculate molecular mass of Fe2O3. This comes out to be iron is 56 multiplied by 2 plus 16 is oxygen multiplied by 3. This is 160. Then moles, calculate moles of Fe2O3. This is mass in grams divided by mR. So mass in grams is 12.5 divided by molecular mass, and this comes out to be 12.5 divided by 160. Let me see what it goes. 12.5 divided by 160. So this is 0.07812 moles of iron. And from the equation, we can see that 1 mole of Fe2O3 produces 2 moles of Fe, and 0.078125 moles of this produces 2 multiplied by 0.078125 moles of Fe. So overall number of moles and then mass of Fe. So number of moles 2 into 0.078125. This is the number of moles multiplied by Mr, that is 56, and this comes out to be 8.75 grams approximately. Remember, multiply by 2 multiplied by 56, 8.75 grams. So answer is 8.75 grams of iron. Okay, so this is as simple as that. So remember that we have solved some of similar questions earlier in this paper as well. So these are some of the things you have to remember. So number of moles is mass in grams over mr is one of the formulas which is extensively used or extensively asked in this exam. And you have also seen yourself that we have used the same formula at least thrice now up till here. Then part D, silicon dioxide is an impurity in the iron ore. Explain how the addition of limestone helps remove silicon dioxide from the blast furnace. So remember, limestone is calcium carbonate, and silicon dioxide is the impurity. Okay, so remember this reaction, what is happening over here. So let me write here. So this is a calcium carbonate. So you are heating it, it is forming CaO plus CO2. And this basically CaO reacts with silicon oxide to form uh, this silicate or calcium compound or calcium silicate compound. So this is what exactly is happening. So let's try to write this thing down. So the calcium carbonate in limestone decomposes to calcium oxide and carbon dioxide. The so calcium oxide CaO and CO2. So the CaO reacts with silicon dioxide under high temperature to form calcium silicate or slag. This is called slag. And the slag is basically removed from this. So this molten silicate, this molten calcium silicate is less dense than iron and floats on the surface of molten iron, which can be easily removed. So saying easily here is not a wide word because the reaction involves pretty uh, you know decent amount of engineering, but still I mean you can say it can be easily removed. Okay. uh, then part E, it says iron is a metal, describe metallic bonding. Okay, so metallic bond. So metals, remember, metals have so the ions of metal or the metals are something like this. So metal elements with look something like this, and there is sea of free electrons available. So the metallic bonding. So just simply the metallic bond is a type of chemical bond that is formed by the electrostatic forces of attraction of the lattice atoms, or so not lattice atoms, I would say lattice cations, and called positive ions, and free moving electrons, or free moving electrons, or anions, or you can also call B localized electrons or anions. Okay, so this is how we can explain metallic bonding. So this is a bond primarily between the positive ions and the negative ions, or the cations and anions, and they are formed, or they are present in the lattice structure of the metal. Okay, so moving ahead, next question is question number 8, and it says this question is about some compounds of sulfur. So part A, dilute sulfuric acid reacts with aqueous sodium hydroxide as shown. So sulfuric acid plus base, salt plus water. Okay, a student titrates 25 uh, centimeter cube of dilute sulfuric acid with sodium hydroxide. Concentration is this, is 0.015 mole per decimeter cube, uh, using litmus as an indicator. An acid of volume 24 centimeter cube of aqueous sodium hydroxide, a volume of 24 centimeter cube of sodium hydroxide reacts with exactly with the dilute sulfuric acid. Calculate the concentration of dilute sulfuric acid. Okay, so now we have to find out the concentration of dilute sulfuric acid. Okay, so from this reaction, what we are seeing, first of all, we have to uh, see what is happening. So 2 moles of NaOH reacts with 1 mole of sulfuric acid. Okay, it's 2 moles reacts with 1 mole. So this is happening. And before that, we have to find out what are the moles for sodium hydroxide which are involved in a reaction here, and from that we can estimate the moles of sodium sulfuric acid, and from the moles of sulfuric acid we can estimate about the concentration. So let's try to solve it. So we have H2SO4 and the volume is 25 centimeter cube. Okay. Uh, then we have sodium hydroxide. Concentration is 0.015 mole per decimeter cube, and 1 decimeter cube is 1 liter, is equal to 1000 centimeter cube. Again, so concentration in mole per centimeter cube. So this centimeter cube, 0.015 divided by 1000 mole per centimeter cube. So this is 1.5 into 10 to power minus 5 mole per centimeter cube. Now, so this is now the concentration of NaOH in mole per centimeter cube. Okay. Now, number of moles of NaOH in 24 centimeter cube. This is 1.15 10 to power minus 5 mole per centimeter cube multiplied by 24 centimeter cube. So this comes out to be 3.6 into 10 to power minus 4 mole of NaOH. So these are the number of moles of NaOH that are used by the student. So now from equation we know that 1 mole of H2SO4 requires 2 mole of NaOH. So if we have this moles, so number of moles of H2SO4, this is 3.6 into 10 to power minus 4 divided by 2. This is 1.8 into 10 to power minus this 4 mole of H2SO4 used. So these are the number of moles of H2SO4 used. Then volume of H2SO4, volume of H2SO4 is volume of H2SO4 25 centimeter cube. So the concentration is 1.84 10 power minus 4 mole divided by 25 centimeter cube. So this comes out to be let me find out that calculator. 1.8 to this is 8 divided by 25. This is 0.072 into 10 to power minus 4 mole per centimeter cube, and mole per decimeter cube is multiplied by 1000. So this is 7.2 into 10 to power minus 3 mole per decimeter cube. So this is the concentration, 7.2 into 10 to power minus 3 mole per centimeter cube is the concentration of sulfuric acid that is used. Okay. Then question number part 2 for this question, describe how to prepare pure dry crystals of sodium sulfate from aqueous sodium sulfate. Okay. So let's see. So remember, when you have to prepare crystals, you have to allow the solution to evaporate slowly, uh, and before evaporation, you have to basically you need to have a super saturated or solution or a saturated solution of the salt so that it starts forming crystals. uh, First of all, so you have aqueous solution. So evaporate the aqueous solution to a saturated solution of sodium sulfate. uh, and how we know that the saturation solution of sodium solution, can say till the point crystals start appearing. And this is a visual check for that solution has reached a saturation state. Once the crystals start evolving, allow the solution to cool. Allow the solution to cool. Crystals will form. Uh, then filter out the crystals. Filter out the crystals and wash them uh, with cold water, or you can also use any organic solvent as well. So, or organic solvent. And in the last step, you can say dry the crystals using filter paper or any other drying mechanism you have. So this is in a way you can form crystals. So remember, the first step for in order the things they are looking for is making up of a saturated solution by evaporation. Number two, allowing the solution to cool, and number three, filtering out the crystals and drying them. Okay, so these are the 3 points which the examiner is looking for, and these are the 3 points for which this question is for 3 points. Then part B, concentrated sulfuric acid oxide arsenic to arsenic 3 oxide. Complete the equation. So we have to complete this equation. So let's see. So we have 4 arsenic here. So let me say add 4 here. Let's see what happens. So 4 here. So oxygen is 6. So oxygen here is technically 4. So we have 4 over here. So we have 6, 7, and 12. 18 and 1, 19 oxygen, and 4 here, and 4 oxygen here. So 6. Oh. So if I add 2, and how many hydrogen? So we have 2 hydrogen here. So we have 2 hydrogen here. Okay. How many sulfur? So we have 6 sulfur here. We have 1 sulfur here. So at least we need to have a 6 here. So let's see, add 6 here. So what happens?
6, so 12 hydrogen, 6 sulfur, 24 oxygen. So 24 oxygen. So we have 12 oxygen here, 6 here. We can't add anything here. We can't add anything here. So 12, 18, and what? How many we have to make? We have to make 24, and we already have 19. So 18 are fixed. 9. So 6. So the answer is add 6 here. So now see if this equation is balanced. So 4, 6, 2, 4, 6. So now this equation is completely balanced. Okay. So this is how you balance it. Just make sure that all the number of atoms on both sides of right and left side of equation are the same. Then next part, question number C. It says sulfur dichloride is sulfur dichloride ClSCl has a simple molecular structure. Complete the dot and cross diagram for molecular structure for molecule of silver dichloride. Include the outer shell electrons. Okay, so for chlorine, outer shell electrons are 7, and we'll draw them with cross. Okay, and for sulfur, the outer shell electrons are 2, and we'll draw them with a dot. Okay, so outer shell electrons x x x x x x, one electron comes binding here. Okay, and then we have uh, not sulfur. Sulfur is 6 to 6. Yes, 6, 4, 6 comes here. 1 1 1 1 1 1. So now this is how we can draw this thing as well. The next question, part D, melting point of sulfur. So before I start with this, so remember, include the only on it says include only outer shell electrons. Some of the mistakes students make, they just simply draw these ones only. So this is not the right choice to do it. I mean, you will not get complete credit. So you have to draw all the outer shell electrons. So for sulfur, for chlorine, both. Okay, so make sure that you draw something like this. Then part D, it says melting point of sulfur dichloride is minus 121 degree. The boiling point of sulfur dichloride is 59 degrees centigrade. Reduce the state of sulfur dichloride at room temperature. Give your answer. So room temperature is something 25 degrees centigrade or 27 degrees centigrade. So so 25. So this is melting point. So melting point is minus 121 degrees, and boiling point is 59 degrees. So room temperature is somewhere here. So this is 25. So this is in liquid state. Okay. So reason, room temperature is greater than the melting point and less than the boiling point of SL2. This the SCl2 is in liquid state at room temperature. Okay, so this is as simple as that. Okay, so question number 9. Question number 9. It states that lead is a metal in group 4 of the periodic table. and lead ion, an ion of lead has a symbol Pb2 positive 207/82. Reduce the number of electrons and neutrons in this ion. So number of electrons, are actually, if this lead is there, so number of electrons is equal to 82, but it is 2 positive, it means that it has lost 2 electrons. This 2 minus of 2 electrons. So total of 82 minus 2 is 80 electrons. So 80 electrons. Number of neutrons is 207 minus number of electrons. So 207 minus 82. So number of neutrons is actually 207 minus 82, and this comes out to be 125. So what exactly is this? So number of neutrons. So inside nucleus, you have neutrons plus protons. Okay, so protons 82, electrons 82 minus 2, 80, neutrons, this overall atomic number 207 minus 82 number of protons, and that becomes equal to neutrons, and it is 125. This is how what is 125 comes. Then part B, lead 4 oxide PbO is an oxidizing agent. So remember, oxidizing agent. So for describe a test for oxidizing agent. So remember, a test for oxidizing agent is simply add Ki or potassium iodide or Ki solution. Then observation, the color changes from colorless to reddish brown. Because of lead iodide precipitate. Okay, so this is how this will go. Next part, it says lead 4 oxide reacts with concentrated sulfuric acid to form lead chloride, PbCl4, and water. Okay, construct this equation. So for lead oxide, remember PbO2 plus sulfuric acid, HCl. What is formed? PbCl4 plus H2O. Now we have to balance this equation. So Cl4, so there are 4 Cl, so let's have 4 over here. 4 Cl means 4 H2, so 2 over here. Now this equation is balanced. So this is how this equation will look like. Remember, always write balanced equation. You will not get credit if you're not going to write balanced equations. Part C, when lead 4 chloride is warmed in a closed container, an equilibrium mixture is formed. The forward reaction is exothermic. This is describe and explain the effect, if any, on the position of equilibrium when the concentration of chlorine is increased. So you have basically at equilibrium, you have increased the concentration of chlorine. So at basically equilibrium, what's happening? The rate of forward reaction is balanced by rate of backward reaction. So if you increase the concentration of chlorine, rate of backward reaction will increase. And what eventually form will have lead chloride form at the equilibrium. So let's try to write it. So at equilibrium, the rate of forward reaction is equal to the rate of backward reaction. So increasing concentration of chlorine will increase the rate of backward reaction. We'll have more PbCl4 will be formed PbCl2 will react with Cl2 to bring the reaction back to equilibrium. So basically, if you change or if you increase the concentration of chlorine or any constituent at the equilibrium reaction, the equilibrium will shift and the reaction either forward or backward will start proceeding till the time it reaches another equilibrium. Okay, so this will happen over here as well. Increasing the concentration of chlorine will increase the rate of backward reaction, and that backward reaction will carry on till uh, another equilibrium is reached between the chlorine and PbCl2 reacting with each other. Okay, then uh, part 2, it says describe and explain the effect, if any, on the position of equilibrium when temperature is increased. Okay, so increase in temperature. So see if, so lead chloride is warmed. So if this is warmed and this reaction is exothermic in nature. Okay, so increase in temperature in this case will result in backward reaction, again more PbCl2 form. So what will happen again? Uh, so increase in temperature results in increase in backward reaction. Have more PbCl4 will form. The temperature from surroundings will decrease to decrease compensate the increased temperature and this uh, decrease slash or you can say this decrease in energy uh, so basically you are forming PbCl4 PbCl2 plus Cl2. So if you increase the temperature here, so this is an exothermic reaction. So exothermic, so these bonds are breaking and these new bonds are forming. So bond formation is exothermic, bond breaking is endothermic. So since this is a backward reaction, so this temperature is absorbed over here, and this allowed technically to new bonds forming at this end. This is actually uh, an endothermic process. So this decreases. So I mean, just so the temperature from the surrounding will decrease to compensate the increased temperature till the new equilibrium is reached. Till new equilibrium is reached. So this is how it all goes. Uh, then part D, it says name lead salt which is soluble in water. So remember, all nitrates are soluble in water. All nitrates are soluble. So this is an interesting thing. Sometimes we have to name salts. So all nitrates are soluble. Whatever metal ion you have, make a nitrate, and that will be soluble in water. In water, basically, all nitrates are soluble. Uh, generally, yes, for solubility, this is the best one because if you have so nitrates are generally NO3 negative. And then there are chlorides, there are iodides, there is sulfates. So again, for chlorides, iodides, all chlorides again are soluble except silver, lead, mercury. Silver, lead, mercury not soluble. Similarly, sulfates, silver, lead, mercury, calcium sulfates are not soluble. Carbonates are mostly insoluble, or hydroxyl ions are mostly insoluble or insoluble in water, except sodium, except ammonium hydroxide, or except ammonium carbonate. So similarly, so best answer is go with a nitrate. So all soluble, all nitrates soluble, or all soluble salts are generally nitrates. So anything, lead salt, lead nitrate, PbNO3, or and what salt is this? This is Pb2. So Pb2, or you can sort lead to nitrate. Okay, this is the best answer, and wherever anything, something or anything related like this is asked, go with a nitrate. Okay, so here this one was the last question, and I hope you have learned something from all this exercise, and I wish you all the best for your upcoming exams. Thank you very much for listening. Take care. Bye bye.